All right, we want to look at conditional expectation. And it begins with pointing out that, we could look at the expected value of x given y is equal to, say, yi, something like that. And so that is, if I want that, that's just the sum. And since I used an I here, I'll use a j. So that's just the sum of the x, j. Usually I use an I with an x. So xj times the probability that x equals xj given y equals yi. And so we can use that if we look at the expected value of the expected value, and that's interesting, of x given y, like that. Now that is equal to the expected value. Well, I need a sum, I guess. Okay, so I'll sum over the i's, and that will be the expected value of x given y equals yi times the probability that y equals yi. Okay, so so that's just the definition of this expected value, because we have e, the expected value of this thing, that would be over the y's, and so that's our function over the y's. But now we can go back here, and this part we did up here, and so this is the sum over I, the sum over j of x, j, probability that x equals xj given y equals yi, times probability that y equals yi. And so now what we can do is we can actually use the definition of what we have here. So we've got our sum over the i's, sum over the j's, x sub j, and the definition of this is the probability that x equals xj intersected with y equals yi, divided by the probability that y equals yi. But notice then that's also times the probability y equals yi, and so those cancel. And so now we have, this is the sum over I, sum over j of xj, and this probability here, we can just call that the joint. So now I'm going to change that to an f. That's just f, and if you want, you can put the xy there of x j yi. That's just the joint probability distribution here of those. And so now if we actually interchange the sums, we have the sum jxj and then the sum or the i's of the f of xj yi. But if we sum that over the y's, that's just f sub x. So that's jxj times our f sub x of xj. And that is just the expected value of x. So it turns out that you see this expected value of the expected value of x given y is just the expected value of x. It's interesting. Now, how is that used? Well, that we'll do example 4.8. And in example 4.8, we have a motorist stranded in a snowstorm that can go one of three ways. And so they're here. They could go this way, I guess. That's way one, way two, and way three actually brings them back here. And let's see, the first way is 1 hour to safety. The second is 3 hours to safety. And the third direction, they go in a circle and they come back in 2 hours. And so then the question is, what's the expected time to safety? Well, so we want, if x is our time, so we want e of x, but that's probably easiest to get by taking I equals 1 to 3 of the expected value of x given y, where y is the direction chosen, equals I times the probability of y equals I. Okay, now that is a third in every case. They said they're equally likely to go down any of those three spots there. And so this is 1/3 the sum I equals 1 to 3 of the expected value of x given y equals I. And so now this is this is 1/3 times the expected value x given y equals 1 plus the expected value x given y equals 2 plus the expected value of x given y equals 3. And so that's 1/3. Now the expected time if y equals 1 was 1 hour, I believe. Yes, 1 hour. Plus 2 hours for the expected x given y equals 2, and then plus, well, since we get right back to where we started from, we have the expected value of x plus 3. So this is an interesting, it turns into an algebra problem, but we have the 3 hours to go in the loop Oh wait, I think I got that wrong. Oh, 3 hours and 2 hours. So this should have been 3, and this one is 2. So 2 hours to go in that loop, and then we're right back where we started from, so the expected value of x. So that's interesting. So now we have to set up our algebra problem. We have the expected value of x is equal to 1/3. So this is 5, 6. So 6 plus the expected value of x. And so this means we have 2/3. The expected value of x is equal to 2. And so the expected value of x is equal to 3 hours. Interesting. So there you go. Now that's the expected value. In actuality, a person could keep going forever. But there is example 4.8 and this conditional expectation. So it looks a little hairy with all this stuff back here. You know, this expected value of the expected value of xy is the expected value of x. But, you know, in practice, I'd say, you know, it's pretty straightforward. It's just this idea of splitting, you know, if x could be dependent on some other variable y, it's splitting it up into those cases and looking at the expected value for each of those cases. So it's not really too bad. This put a little strangeness in here because of the loop, but other than that, I would say, you know, pretty straightforward. Okay, so there's that one.